Hi guys.
So I'm just gonna have her use the stick mic.
Okay, perfect.
Okay. I just can't do it. I don't think I need to be. I got some general volume. Yeah.
Hey guys, this is Katie. Hello. Okay, all right, I'm going up. Oh, Alyssa, is the clicker up there? Okay, is this on? You guys can hear me? Hello. Hello, everyone. Welcome. Travis, you want to get the doors? Thanks. Okay. Hi, everybody. Welcome to the GRIN2B Family and Research Weekend. Thank you all for being here. I'm Liz Marfia-Ash, president of GRIN2B Foundation and mother to Lucy, who has GRIN2B. Okay, a couple of things just to note. For safety and liability reasons, we cannot have anyone on the stage except presenters. It's okay. Just putting it out there. No one on the stage. Okay. How does this work? Oh, I don't know how this advances. Oh, okay. So I want to thank our sponsors they're the reason why we're able to put an event like this on. It's obviously very costly to put on a conference, and we are very, very grateful to all of our sponsors, many of whom have supported our events in the past. Okay. So another reminder, I put this in the email that you all got, but due to sensitive topics, we cannot have any children in the room. Our last session today, the GRIN2B family story with Laura, trust me, you do not want your kids in the room. Laura is lovely and a wonderful person, but we need to not have children in the room for that. And then also for Saturday, our keynote speech, Madeline Cheney, the topic is going to be grief, and we don't want children around for that. It's not appropriate. And then just a general rule of thumb, obviously, we know there's no childcare today, and it's totally fine for the kids to be here right now. But tomorrow, we would really like to minimize the children in the room as much as possible, partially because we are live streaming and we have people watching remotely, and we want them to be able to hear everything. And obviously, we know that GRIN2B children are not quiet. We love them, but they're not quiet. But obviously, there are circumstances, and if you aren't, you just have to have them in here. We totally understand. We're not going to kick you out. Try to stay towards the back and maybe minimize movement. Okay. A couple reminders. Simon Searchlight will be here tomorrow and Sunday. They will be just down the hall and to the left. I think it's conference room 7? Is that right? Okay, 7. And so if you want your GRIN2B child to have their blood drawn, and then that will be stored in their biorepository for future research use. I highly encourage you to do it, but obviously it's optional, and if it's going to stress out your child, of course, don't do it. Also, I just want to remind you that Caitlin Hudak is here from the University of South Carolina. She is going to be conducting her biogene study, which is a EEG-based study, and she has time slots available. Hopefully some of you have already signed your child up. Many of us have already had our children participate, and Caitlin will be talking about her study more tomorrow, so you'll be able to learn about it. Okay, and then later, probably during break, we are going to have this book, the Honeybee Board Book. It's a small children's board book. We're going to have copies of this for sale. This book was written by Sarah Nunnally, who is a GRIN2B mom. She's not here with us this weekend, but she wrote this book in honor of her daughter, who has GRIN2B, and she is donating the proceeds of this book to GRIN2B Foundation. So it's a really, really cute, I mean, obviously it's geared towards, young children, but it's a really cute keepsake to have. So if you want to buy a copy, you will be able to do that in the lobby later today. And we'll have it throughout the weekend as well. Okay, and then Sunday in the afternoon, we have our family outing at Wings Over the Rockies Air and Space Museum. So some of you have already RSVP'd on the Google form I had sent out. So, but if you still want to go, just let us know. Either fill out the form or let Alyssa or myself know. Alyssa is over there in the yellow dress. She is our executive director. She can help you out with anything you will need this weekend. So let us know, especially if you need help with transportation, because obviously we have to figure out how we're going to coordinate that. And then, quick plug for our Be Active for GRIN2B fundraiser. This will be our 5th annual, or our 5th time doing it. So it's a GRIN2B run, walk, and roll fundraiser all throughout the month of September. And basically, we just encourage families to create their own, any kind of Be Active event you want, whether people do walks, people do dance parties, people do Zumba parties, people have done all sorts of things, any kind of activity you can think of, and then we provide you with the platform to collect donations, and you'll be able to get t-shirts with your fundraising team name on it, and we have all sorts of materials in your yellow folders on how to do that. So another quick plug that if you did want to do this, This is a great weekend to decide if you want to do it, because we can send you home with extra bracelets for your event. And, oh, that's all I got. So I am going to now pass this over to Katie, who is going to do the Genetics and GRIN2B 101 presentation. That's it. Okay. Bye, guys. Thanks.
All right.
All right.
Perfect. All right, can you guys hear me well? Awesome. Okay, clicker, great. My name's Katie. I am a genetic counselor at the Children's Hospital of Colorado. I've been there for about 2 years in the neurology department. And today we're going to be doing a little bit about Genetics 101 and GRIN2B. I know that genetics can kind of seem like a foreign language. The reports, I think, are notoriously difficult to read and really even know what you're looking at if you don't have a background in genetics. So really, I just kind of want to break down some genetics basics and then go through an example report, and then hopefully you guys will have just some practical information to take away and just feel like if you have a report to look at home that you can kind of decipher it a little bit. So we're going to start with doing some background in genetics. So I might be using my hands a lot as I describe things. That's usually just what I do. So our bodies are made up of trillions of cells, and inside of almost all of those cells, we have a set of our genetic information. And this photo is kind of nice because it shows you what that looks like if we were to look at it underneath a microscope. So we have our DNA, which really is the instruction manual for our bodies. And it's wound up really tightly into this structure that looks like an X, but it's actually a chromosome. And I kind of think about it as like yarn wound up into a big yarn ball. And then certain segments of the DNA represent different genes. So this is an image of what our chromosomes would look like if we kind of put them underneath the microscope and lined them up really nicely. You'll see that we have 23 pairs of chromosomes overall. We have 1 through 22. These are called our autosomes, and they're the same between males and females. And then the last pair of chromosomes, pair 23, these are our sex chromosomes. Males typically have an X and a Y. Females typically have an X and an X. I think what's good to point out with this slide is kind of like what I've already said, how we have two of each chromosome. And so we actually have typically 2 copies of each gene. And so chromosome 12 is the gene that GRIN2B is on. It's going to be near the top. And so we're going to have 2 of those, 1 on each. So a little bit more about DNA. DNA is really, like I was saying earlier as well, the instructions. We can think about these nucleotides like letters, and those letters are A, T, G, and C. And they are repeated and kind of ordered in a whole bunch of different ways to give our bodies that instruction. We know that 3 nucleotides is a codon, and 1 codon tells us what amino acid the body needs to use when it's building the protein. So this is not something that we really need to decipher, but it's really showing how the letters translate into amino acids. So like we'll have a G, we can kind of follow it to another G and another G, and we have a glycine. Or if we had a G and then we went to an A and a G, we're going to have glutamic acid. And so it's just kind of cool seeing how these letters actually translate to information that our bodies use. And amino acids, you guys have probably heard about these in like magazines talking about diets, like maybe you hear like quinoa has a lot of amino acids in it, or tryptophan is in turkey. And this is actually stuff that our body uses to build these proteins. I think about them as kind of like beads on a string. So this image is nice because each bead represents an amino acid, which we know was coded for by one of the codons here. And so all of those beads on the string together are going to be the protein that the body is trying to ultimately make. And we know that each gene really just gives information on how to build a specific protein. So the GRIN2B gene is going to be telling us how to make this GRIN2B protein. And what's interesting background, I think, to have is what the body does with these newly built proteins. So we still have this bead on a string, but the amino acids actually have their own, oh, I'm forgetting the word for it specifically, but they have charges. So some of the amino acids are going to be positively charged, some of them are going to be negatively charged. And so what it does is that those beads on a string kind of like fold into what the correct structure is supposed to be in the end. And so we're going to go a little bit into different types of genetic changes and different variants now. You know, as I've been saying all along, instructions. If we have those letters in the instructions change, it makes sense that it's not going to be telling us the same thing anymore. And this diagram, I think, does a good job of showing how even just one letter change can go from the gray cat ran down the hall to the gray cat ran down the ball. And if you're trying to be really precise about building a protein, even something as small as that can change ultimately what the body has to work with. And so there are a whole bunch of different kinds of genetic changes that are out there, and this diagram kind of goes through some of them. I know that with GRIN2B, most of the genetic changes that we're going to see are sequence variants, which really just means the spelling is different. Variant is just a fancy science word for saying genetic change. And so a missense variant is where we're going to have one of those letters swapped, and it's going to result in one amino acid changing. So we've kind of talked about this one already with hall turning to ball. We can also have insertions where extra information is put into that DNA. So the gray-green cat ran down the hall. We can have deletions. So the gray blank ran down the hall. And we can even have duplications where, say, the gray cat ran down the hall. Another type of interesting genetic change is a nonsense variant. And what this does is it changes one of the letters and it turns the codon into a stop codon. And so instead of them putting in a new amino acid, it's actually telling the protein, you're going to stop right here. And so they're not going to finish building the rest of that protein. And then another type of genetic change that this diagram doesn't talk about is a frame shift variant. And really what that is you're going to be inserting a letter, and it's going to be changing the reading frame. So looking back at this again, we can see the first three letters, AAA. Well, say we changed that third A to a T, it's going to go AATA, and then all of those three codons are going to be kind of shifted one back, and they're not going to be coding for the right amino acid anymore. And so that's a way that the protein can be built incorrectly for a large chunk of that entire protein. Okay, so I think that it makes sense overall that the gene tells us how to build the protein. And if those instructions don't make sense, it's not going to build the protein as it's supposed to. And if that protein isn't built right, it's not going to function right either. Proteins are really specific, and they're kind of almost like a lock and key function where if that protein isn't shaped quite right, then it really might not be able to work the way that it's intended to. So types of genetic tests, there are so many on the market now, but these three are maybe ones that you guys would have come across in your journeys so far. The first two may be less likely than the last one, sequencing. Karyotyping, this is one of the oldest types of genetic tests that we have. It's going to be visualizing the chromosomes. And so on like the second slide that I had, we looked at the pairs of the 23 chromosomes all lined up. And that's really exactly what this test is doing. There's laboratory scientists who are looking at the cell underneath a microscope, taking a picture of it, and then kind of cutting them out and arranging them into those pairs. And so this is a test that's good to use if you're suspecting that there might be an extra chromosome or a missing chromosome, or if you're suspicious that some of the chromosomes might be rearranged, like maybe you have a part of chromosome 8 that's on actually chromosome 12. It's still going to be the same amount of genetic material, but where it is different in those cases. And that's where karyotyping can be great. This is also called chromosome analysis sometimes. Chromosomal microarrays, we're still ordering these quite frequently. These are going to be looking for extra or missing genetic material that's going to be too small to see on the karyotype with that microscope. But this isn't going to be visualizing the genetic material. So sometimes we're going to know they find some extra information, but we don't know where it is. And depending on the situation, that might be helpful for us to know, and we might end up ordering a karyotype afterwards. Sometimes we're able to kind of order both of these just right away at the same time. And then sequencing. This is really where we're reading those genes for spelling mistakes. There are so many sequencing tests. One of the big ones is going to be panels, where the company is including only specific genes. Usually they're going to be picking those genes with a team of bioinformatics people, where they say, yes, we know that all of these genes can be connected to genetic conditions where something like epilepsy is a symptom. Historically, with genetics, we would order single gene testing, where we'd say, we're most suspicious of this gene, and we'll order that. And if it's negative, we would order another one, and then another one from there. And as you can imagine, or maybe even know yourselves, that's a long and expensive process. And we know, especially with a lot of the symptoms that kids with GRIN2B have, they can kind of overlap with a whole bunch of different genetic conditions. And so the likelihood of us picking the right gene to test right away, it's not that high. So recently, the most used genetic tests, I would say, would be whole exome sequencing, and not quite yet, but we're almost there, whole genome sequencing. And really, instead of picking certain genes, we're just going to be looking at all of them, and we're going to be reporting to the laboratory the symptoms that we're seeing in the patient, and they're going to use that information to really analyze those genetic changes to see, okay, do we have a suspicious genetic change in a certain gene that might overlap with these symptoms? And that's kind of how they narrow down what they're going to report, which if they don't find anything suspicious, it might be negative. A question that I get sometimes is, what is the difference between whole genome and whole exome sequencing? I know that this slide is pretty busy, but the differentiation between them is Whole exome sequencing is going to be looking at all of our genes, but it's only going to be looking at certain areas of those genes. It's only about 1 to 2% of the gene overall. It sounds kind of strange, but most of the gene does not give us usable information. We call it the introns, and instead of those letters being in a sequence that tells us how to build something, they're kind of just random, like if you were to just kind of like clack onto like a keyboard. And so historically, we would call this junk DNA. Introns are junk, we thought. And for the most part, that's still true, but with more research and more time, we've found out that sometimes there are genetic changes in these intronic areas that could be related to genetic conditions. Usually, they're going to be genetic changes that are closer to the start or the end of one of the exons. And so whole exome sequencing, it's great. We call it well, it's a very broad test. We don't have to, decide what to pick. And when we get a negative result with whole exome sequencing and we're still quite suspicious that a genetic condition might be present, that's where we're starting to talk about whole genome sequencing these days. Of course, insurance doesn't really like to keep up with, I think, the evidence with some genetic testing, and so they're not quite approving this so much yet. But I think that it's going to be talked about a lot more in the next 5 years, and especially even in the next 10 years. It's possible that we're going to be using less panels and instead going more towards larger genetic tests sooner to hopefully get an answer more quickly and do it at the end of the day for less cost. Of course, there can be pros and cons to this. So going into an example report, this is a table that I just sort of put together. This is a real GRIN2B variant, but this table is really representative of the types of tables that I'll see on genetic test reports, even amongst different laboratories. So kind of just going right through the different columns, they're going to list the gene first. Of course, in this case, it's going to be GRIN2B. And this is a gene that codes for a protein that we know is really important for this NMDA receptor. Now, this is one of the things that I always like to talk to families about, the variant information, because it truly just looks like a bunch of letters and numbers, and what the heck would this even mean? But this C dot really means what number, what letter is going to be impacted. So say with this GRIN2B gene, we see that it's C dot 2,430. We know that there's going to be a genetic change at letter 2,430. And instead of having a cytosine, they're actually changing it to an adenine. And so underneath that, we have this P dot, and this is really saying how the spelling change is expected to change how the protein is built. And so in this case, we see that it's supposed to be a serine at amino acid number 810, but instead it's an arginine because of that one letter change. And so I tried to kind of explain this a little bit and use some different colors. Really, I just wanted to show that at this last codon in blue where it says AGC, we know that that AGC is coding for that serine, but if we're changing that C to an A, it's actually going to be changing this to an arginine. And we know that because of the charges of those amino acids, this one amino acid change could potentially really change how that protein is folded together and how it ends up working. So this is really just kind of a visual for what we're talking about. We're seeing how the genetic information is actually being built into this string of beads, aka the amino acids that cumulatively are a protein. And on the side, we also just have all of the amino acids listed and their different abbreviations. So zygosity, this is a funny word, and it's a lot simpler than it sounds. Like zygosity makes me think about something like, is this going to be related to zebras? What is this? But heterozygous, really what this means is we know that we all typically have 2 copies of this GRIN2B gene. And heterozygous just means that they found this genetic change on 1 out of those 2. And so this is a picture just demonstrating what we're saying as well. In the middle, we see that these 2 chromosome pairs are labeled heterozygous, and we see that there's a big B and a little b on both of them. Another type of zygosity is homozygosity, which, like it sounds, it just means that you have the same genetic change on both of those gene copies. And so on the right, we see a little b and a little b, and on the left, we see a big B and a big B. Mode of inheritance, this is basically saying what is the inheritance pattern, or what do we know about how that condition can sometimes be passed along in families. Of course, we know that with GRIN2B, this is typically a brand new genetic change in the child, and we can talk about that more as well. So really similar to heterozygous, what autosomal dominant means, which represents this AD, is this just saying, again, we have 2 copies of this GRIN2B gene. One of them has a harmful genetic change on them, and we know that if you have 1 harmful change, that's sufficient for somebody to have symptoms of that genetic condition. Kind of as an alternative, we sometimes talk about autosomal recessive conditions, where we know that you need both of your gene copies have to have a harmful genetic change in order for somebody to have symptoms of that condition. And so autosomal dominant in this case, on a report like this, isn't telling us anything about if it might have come from a parent, but it's really just telling us about how many genetic changes do you need in order for you to have symptoms of the condition. And so de novo, I think that this is a Latin word, and really it just means that this is brand new in that child and was not inherited from either of the parents. And we know that with a lot of the testing that we're doing these days, especially whole exome sequencing, we're actually gathering parents' samples right at the beginning, at the same time that we're getting samples from the child. And so when we get the report back, it's automatically going to be telling us if this is something that if this genetic change was seen in either of the parents as well. One of the most important things to know about de novo variants is that they're nobody's fault. And there's nothing that we can do to cause them or to prevent them. It's really just random error that our bodies have. You know, I've already talked about like clacking on a keyboard with introns. I kind of think about de novo variants as being like myself again typing on the computer. Every once in a while, naturally, I'm just gonna make a spelling mistake. And we do have a backspace key, and so most of the time I'm gonna catch it and I'm gonna be able to backspace and fix it right away. Our bodies typically have that ability, but just like us, sometimes we make a typo and we don't notice it, and it just kind of gets included into whatever we're typing. And I think that this is a good time to talk about mosaicism as well, which it's not something that we see too commonly, but it's common enough that it's good to know what it is. Overall, mosaicism just means that somebody can have a genetic change in some cells, in some areas of their body, but not others. I didn't have a good non-copyrighted diagram to show you guys, but you could kind of just imagine like almost like splotches where maybe I have some of the genetic change like on my leg and some of it in my arm. And the traditional genetic testing that we have sequencing is pretty good at being able to detect high levels of mosaicism, meaning if we know that that harmful genetic change is present in a lot of the cells, it's going to be pretty good at identifying that. Sometimes the lab will say, hey, we found this genetic change and we think that there's mosaicism. Our technology is not validated to tell you to what degree, but maybe you should do some follow-up testing. And so at that time, we'll usually try and figure out what follow-up testing would be useful to maybe find out, how much of the body has this genetic change or not. One of the tricky things is that we're not sampling all different types of the body. Usually we're doing just a blood sample or like a cheek sample. And so maybe the genetic change isn't in my cheek and it's not in my blood, but it's in some other type of body type that this isn't looking at. Basically, it can just be hard for the scientists to find this because they have to know where to look. And obviously, we don't all want to have samples taken from a bunch of different parts of our body. Germline mosaicism is another type of mosaicism where we have a genetic change in some parts of our body, but not others. And in this case, it means that it's present in the egg or the sperm cells, but not in the rest of the body. And so, like I've been talking about with our traditional genetic testing that we have currently, we're not able to detect this because if we're looking at those cheek cells or blood cells, it's not getting a sample from those egg or sperm cells. And so we know that for families who have a child with a genetic condition caused by a de novo variant, a variant that's brand new in them, they're going to have negative genetic test results come back, most likely. And in these cases, even with that negative test result from the parents, we're not able to rule out germline mosaicism just because it's not able to look at that with what we have at this time. We think that this is quite rare. It's really just a theoretical risk that we always like to point out because in genetics, we're often very afraid of saying any of the absolutes, 100% or 0% chance. So really, we would say for parents who had negative testing themselves, there is a theoretical chance that they could have germline mosaicism, but it's probably a less than 1% chance that this would be the case and that they would have another child with the same condition. So lastly, classifications. In this case, this is a pathogenic variant, which really just means we know that it's a harmful genetic change. There are typically 5 categories that we use for variant classification. Most laboratories are going to be classifying variants in almost the exact same way. There's an association of geneticists, it's the American College of Medical Geneticists. They've come out with guidelines many years ago talking about what criteria you should be using to help classify whether a genetic change is pathogenic or not. And so most labs are going to be using these guidelines, but with maybe a little tweak or two. They are always going to be talking about their classification process in the usually the last pages of the report in nearby the risks and limitations sections. And usually laboratories are going to be adding the evidence that they used onto the lab report as well. So here's the 5 different classifications. It's on a continuous spectrum. So variant of uncertain significance is right in the middle. And I like to think about this one as being like a truly neutral category. It means that we just don't have enough information or enough evidence to say whether it's a genetic change that might be harmful or not. Of course, this is a hard answer to get sometimes because we want to know. We want to know, is this something that's might be impacting my child or not? But fortunately, the healthcare providers and the laboratories, they really want to be systematic in evaluating these because they don't want to make the wrong call, and they don't want to have patients be making medical decisions because of this that they shouldn't be. And so with this, I call it a VUS in the middle. We know it's a neutral category. You're going to have evidence to either prove or help prove that it's harmful or pathogenic, or you even need evidence to show that it's benign or normal. We typically think about likely pathogenic and pathogenic being synonymous with like a positive result, meaning we probably found an answer, and benign and likely benign is going to be the same as negative. Usually they're not even going to be reporting benign or likely benign variants on the genetic test report, because if they did, they're going to be listing thousands of different genetic changes. They're probably going to be reporting on a VUS. Types of evidence that they use to help decide whether something's pathogenic or benign are things like, have we found this genetic change in others? Have we found it in other people who've been affected? What were their symptoms? Have we seen this genetic change in the general population where we're assuming that they're generally healthy? We can also use evidence about being de novo to potentially classify something more into likely pathogenic or pathogenic, where we have negative parent test results. And then there's also, really interestingly, laboratories have their own almost like prediction modeling software where they can say, okay, we have this genetic change and we're predicting that it's going to be impacting the protein in this way that might be harmful or not. And so, like I said, they're typically going to be listing this on the report. And so it's usually something that I'm going to be talking about with the families that I'm seeing, just saying, what do we even know about this genetic change? Usually, in the case of GRIN2B, it's going to be a genetic change that it's definitely not in the general population, and it's maybe never been seen in any other reported cases before either. So this is the end of my presentation, but I'd love to answer any questions. Like I said, I know that genetics is kind of like a foreign language, so happy to talk about anything, or you can find me around if you want to chat a little bit more. So, any questions? It might have been long. All right, well, thank you so much for letting me speak. It's a pleasure seeing you guys. I love seeing patient organizations. Whenever I see that a family that I'm meeting with has a condition where a patient organization exists, it always makes me really happy because I know that they're going to have a chance to hopefully connect with other people, and we know that there's probably researchers who are working on that, and that is just so much hope, and it gives some, a family something that they can turn towards. So thank you so much. Break until, I forget what the next session is called, but I think now is just break time.
Thank you.
Hello, everybody. Hello, hello, hello. Hello. We're back. Hi, everybody. I'm going to introduce our next or final speaker for the day, but first, I do want to give a quick shout out to Caitlin Hudak, right there in the back. She's waving her hands. Mainly, I'm pointing her out because she, as I said earlier today, she's going to be conducting the biogene study, the EEG study. So if you want to participate and you haven't already signed up, go and tackle her. Oh, okay. Cool. Okay, so I would like to introduce our final speaker. I didn't write any sort of formal introduction, but I just want to say that I love her very much. She is a fellow GRIN2B mom. She lives just 30 minutes from me, and I just think she's so brave and so special, and I'm so proud of her for sharing her story about Ben today. And so I would like to have Laura, sorry, making this very awkward. Oh, you know what, before Laura comes up, I just realized I've never properly said hi to anyone watching on the live stream, which maybe is like 8 people, but hi everyone watching. Phil, if you're watching, hi. Thank you all for watching remotely. And now Laura Kurek, everyone.
You don't have to come back. It's okay. I'll let you know if I do. Thank you. Whew. Okay. Hi, everybody. Do I have slides? There we go. My name is Laura Kurek. I'm the mother of Benjamin Kurek. Ben had GRIN2B, and he passed away in September of 2021. He was 3 years old, 3 years, 2 months, and 5 days old when he passed. And this past Tuesday, we celebrated what would have been his 6th birthday. It has been a very excruciating few years without him, but I'm really honored to be able to share this with all of you. So let's hope I can get through this, because I've not really done anything like this before. All right, let's see. Okay, so Ben was the first child for my husband, Max, and I. He has 2 little sisters, Brooke, who is now 4.5, and Avery, who's 2.5. I was actually 6 months pregnant with Avery when Ben passed. So she never got to meet him, but you can see from the picture, he had lots of snuggles with her from the outside. Brooke was his biggest fan, always wanted to help with all of his care, loved being around him, still lives on in her mind like he's never been gone. So she's been a big light through all of this. All right, so before I go too deep into everything, I did kind of want to say something about choosing to stand up here and tell his story to all of you. I would talk about Ben literally anytime, any place, to anyone, at any opportunity I had. So when I was given this opportunity, it was a no-brainer for me that I would do it. But the people that I'm most hesitant to tell his story to are all of you in this room. I don't want to scare you or make you worry about your kids any more than you already do. But I know the reality is that me standing up here talking about it isn't going to be the first time you've thought about it. And Ben was very, very medically complex. It was much more than just a developmental disability. I know having a child with a condition so obscure puts a lot of different kinds of fear inside of you, especially when you keep hearing about another child passing, and another, and another, and another, and another, and another. That's 6 of our GRIN2B kids that have passed away that we know of. When we got his diagnosis, we were told that it wasn't fatal, but I kind of think we need to start reconsidering that a little bit, especially in the medically complex children. I'm not going to go really deep into the whole diagnosis journey with him. I knew pretty much immediately from the first few days of him being born that something was going on. It took until he was about 4 months for a doctor to take my concerns seriously. And then after that, he was hospitalized for 11 days trying to figure out what was going on and starting genetic testing. These are just kind of a few quotes that have always stuck with me that I heard from different doctors. And the biggest one is the one at the bottom. When he was admitted for 10 days, losing weight, failure to thrive, a doctor told me that I just needed to go home and get some rest, and it was just in my head. So going from hearing that to now having a child who's not here anymore still is really difficult to think about. So I know the feeling of the beginning stages of feeling so dismissed, and I thought maybe I was just the crazy one, but I really wish that would have been the truth. So we got his diagnosis just after he turned 1 through the whole exome sequencing. There's his variant, it's a loss of function. There are other children with his same variant that aren't medically complex like he is. So these were kind of the main things that we dealt with in terms of his day-to-day life. He threw up constantly. We eventually realized he had pyloric stenosis, he had motility studies, and a lot of his symptoms were GI related. The chronic constipation, he actually ended up, oh my God, where am I here? He ended up getting an ileostomy because he could not have a bowel movement on his own ever. He initially got an NG tube, changed to a G tube, changed to a GJ tube, a lot of feeding difficulties. He had really he was very hypotonic, so not much support. He couldn't sit up, barely hold his head up. So after he got his diagnosis, somehow things kind of started to get worse. He was very tall and thin, like most of our kids are, and really struggled to gain weight. So on his 2nd birthday, he was admitted to the hospital and had an NG placed. They essentially were just looking at the numbers on the scale, wanted to pump him full of nutrients. It just made things worse. He started vomiting more. The constipation issues worsened. We had to do rectal irrigations every single day, but he would still be admitted for a bowel obstruction at least once a month. So the vomiting was one of the huge things that affected our life. We couldn't do anything, we couldn't go anywhere because he was just always throwing up. So obviously countless EEGs. I did kind of want to point out too, like the January 20th picture, that is right before he had his G-tube placed, and then the August one about 6 months later, and you can see that even though we're pumping him full of stuff, not gaining weight. So it just kind of, looking back on it now, it seemed like it was more focused on him actually gaining weight, which with our kids I don't think is really the goal. It's just to keep them nourished. Yeah, just thought that was kind of interesting. So, one admission, we'd been in there, the hospital for a few days, gone in because of vomiting and screaming and neurostorms. He would scream for hours on end with no reason why. So, one of our admissions, we had been in the hospital for a few days and nothing was changing, nothing was helping. I just wanted to take him home because that's what we deal with at home every day anyway. But they wouldn't let us leave because they didn't know what was going on. At that point, I had asked to consult with the palliative care team, and they took one look at him and were astounded that no one had ever suggested he be on palliative before, not because he was dying or they didn't think he was dying, but because he was just in such agony and suffering. So after that, we were able to go home and we started seeing hospice at home. It sounds bad and it's a very difficult decision to make, but it ended up being the best decision we could have ever possibly made for him. They were willing to try unconventional things that no one else would be willing to. Our lives completely changed for a few months. They started him on Haldol for vomiting, and he stopped throwing up. He just completely stopped. After all that time, you know, the one medication, and then he stopped. So we were getting a little bit of normalcy back in our life. Ben was actually really happy, and we had a few months of really quality time with him that I believe we would not have otherwise had if we didn't start with hospice. So, $1 million question, what happened? Something happened in the beginning of August that changed him. He went from the best point in his life to the worst, and we couldn't figure out why. He'd become less responsive. He was having more neurostorms and hour-long screaming episodes. He was either sleeping all day or not sleeping at all. That's a picture of him going to his first day of school. In his wheelchair, you can see he's just completely passed out. He made it to his second day of school and then never made it back. At that point, he had been awake for 2 days straight without sleeping a minute. And he was just acting completely different. So we brought him in for another admission, which, I mean, you don't think much of it at this point, we were constantly there. This time was different. They couldn't get him out of the state he was in, and they couldn't get him to fall asleep. Test after test came back normal. They thought he might have delirium from not sleeping and recommended we put him in a medically induced coma for a few days to see if that would help. It took them 3 days and much more sedative than they expected to finally get him to go to sleep. He was out of it for about 3 days before they started reducing the medication for him to wake back up. And the second he woke back up, it was all the same. He was still screaming. The only other option they gave us at that point was to intubate him with the understanding that he may not recover because of how weak he was. After 12 days inpatient, we made the choice to bring him home and follow up with hospice. The night that we brought him home, He didn't tolerate any of his feeds. He couldn't have a drink of water without agonizing screaming. And at this point, we realized we were keeping him here for ourselves, not for him. We had the talk with hospice and made a plan for his comfort. We stopped force-feeding him. We left the hospital September 13th, and that picture on the right is his last day ever in the hospital, which obviously very sad, but it also makes me happy because he doesn't have to be there anymore. We left the hospital September 13th, and for the next 9 days, we held him so close. We were able to tell him how sorry we were for the unfairness that his life was, and be able to spend time, he was able to spend time with his sister and family and friends. He passed away in our arms on September 22nd at 5:36 a.m. No one knows what changed or why, and no one knew how to fix it. The amount of blame and guilt that we hold as parents for what happened is so heavy because we have no other answer, just to blame ourselves. It's not okay. We deserve answers, we deserve research, and these kids deserve to live a long, happy life. When is that going to happen? How can we make it happen? Ben did his absolute best for the GRIN2B community while he was here, and he continues to do that even though he's gone. He donated his brain to Autism BrainNet. He desperately wants to help his friends, your kids, to not have to suffer like he did. I hope I'm making him proud when I tell his story, because the pride I have from him being my son is insurmountable. I made a promise to him before he died that I would never stop fighting for him, and me standing here today is an attempt at that. I want to say thank you to the GRIN2B Foundation for giving me this opportunity. It's such a privilege to tell you all about Ben. It's such a privilege to be here in a room together with so many people that share a common goal. I do want to end on a high note. Although Ben is gone, he's never far away. He lives on in our lives and always will. He had a smile that could melt your heart. The softness of his hair was one of his most frequent compliments. His good days were full of so much laughter and playfulness. Ben has impacted so many lives, and we are so grateful that he was with us while he was. But this has to stop. And that's his birthday on Tuesday. And this is what Ben thinks of GRIN. Thank you. I am. Like I said, I love talking about him, even the hard stuff, so I'm literally an open book. Should I go back up here?
Was there anyone in your life that knew about GRIN2B, like any of the doctors or anybody that you would have had connection with at that time that would have been able to help you, or were you just sort of out alone in the medical world without any knowledge surrounding GRIN2B?
Mm-hmm. So initially, no, but when we first got his diagnosis, the first thing we found was the GRIN2B Foundation, and there is a group of GRIN2B kids in the Chicagoland area. And we ended up seeing a neurologist that was also seeing another GRIN2B child and a GRIN1 child, I think. So there was a little bit of knowledge, but his case was very different than what he had seen before. So, kind of.
Yeah, we knew about Ben. As I said, I live close to Laura, and I literally went and saw Ben like 3 days before he passed, which is like one of the most amazing and saddest moments of my life, was getting to hold him one last time. But yeah, we tried. We just don't know enough. And it was kind of a atypical presentation of GRIN. Any questions? Oh, we have questions.
There we go.
Laura, you talked a little bit about some of the things that were frustrating about the way that providers talked to you when Ben was in the hospital. Can you talk a little bit more about that and what things were frustrating for you and what you wish they would have done differently?
Yeah, of course. So initially, I'm a nurse and I worked in mother-baby for a while. I've been around a lot of babies in my life. When Ben was born, I just kind of knew something was different. Didn't want to be the new mom who is worried about everything, so kind of kept it to myself for a little bit. Brought it up to his pediatrician and said it was just colic and just wait it out, nothing to do. Things got worse. At his 3-month appointment, same thing, oh, still just colic. So we went to a new pediatrician and she immediately took it more seriously because she saw him, not developing as he should be. The day that we brought him into the emergency room for the first time was Thanksgiving Day, my 30th birthday. He had been screaming for like 8 hours. And up until that point, I had been told, just wait it out. And then we get to the emergency room and the doctor said, oh, he doesn't look like a normal baby. Something's really wrong with him. So there have been a lot of insensitive comments. I don't expect doctors to be perfect, but I do expect them to have compassion. And we, especially in the beginning, did not get a lot of that. And then towards the end, because he was so medically complex and we were in and out constantly, it kind of even felt like we were dismissed because we were seeing them so often. Like, oh, them again. So yeah, it was, I think getting the diagnosis at least was validating enough so that we didn't get terrible comments anymore. But still, people say not nice things. Yeah.
Hello. Thank you so much for sharing that. I've heard you a few times, more than a few times, talk about Ben, and every time I feel like I absorb and process a little bit something differently. I had a question about like when he was happy and when he was sad, because I had the privilege of meeting him, and the one thing I remember about him is his beautiful smile. And I know that he had these periods, but I don't even, how did you get through 8 hours of him crying? Was there any indication, or would it just flip just like that?
Occasionally, you could tell if he was getting irritated and irritable, and you could potentially distract him out of it. Otherwise, when he would get in these screaming episodes, it was just time. It just took time, and when I had asked the new pediatrician at what point should we bring him to the emergency room because this is just what our everyday life is like, she said, when you as parents can't handle it anymore. So that's kind of what we did after that 8-hour stint. Couldn't handle watching him like that anymore. But yeah, it would just day to day, hour to hour. When I was looking through pictures for this, I watched a video of one of his neurostorms, and it was bad. And then I looked at the next picture, and it was like 25 minutes later, and he's got the biggest smile on his face. No rhyme or reason. Wish we knew. Wish we knew how to help him while it was happening. It's a very, very desperate feeling to want to help your kid and not be able to. But yeah, definitely just very random. He did not have seizures. He had an abnormal EEG, but at one point too, they thought maybe it was him having seizures during these episodes, but it was confirmed that it wasn't. Okay, anyone else?
I wanted to thank you for sharing your story because not as a mom, but like as a physician, like I'm traumatized by how you were treated. And I promise you that I think about that when I'm with my patients. So please continue to share his story, and I really appreciate that.
Thank you, Nisha.
Okay, thank you. Thank you, Laura. So we are done for the day. I just have one final request. Maybe it will lighten the mood. Or actually, it's a question. How many of you parents have a bee tattoo? Raise your hand. Oh, is it everyone just on this side of the room? We're gonna take a picture of our bee tattoos. Okay, that's it. We're done for the day. Ben wants us to all go have a drink at the bar. I think we've earned it. We will see you all bright and early tomorrow, 7 a.m. Breakfast it's a buffet breakfast. You don't have to get there at 7 to 8 breakfast. All right, good night, everyone.